How is the graph of y equals minus f of x plus 8 minus 5 transformed from the graph of y equals f of x? So, to get us started, let's make a little love note here to ourselves that our parent function, or the basic graph, is defined here as the arbitrary function y is equal to f of x. So this is where we're starting. And the goal here is to define the transformations needed to attain y is equal to minus f of x plus 8 minus 5. So to get us started, I'm just going to leave the function the way that it's written. And we'll read our translations from the left to the right. So the first thing I'm noticing here is this negative in front of the function. So let's think about the definitions of our transformations to identify what's going on. So let's recall that if we have y is defined as a minus f of x, where that negative is on the outside of your function, this indicates that we have a reflection across the x-axis. So that is our first transformation that we need. So now looking back up at our given function here, again moving from the left to the right, the next thing we see is this plus 8. And now notice the plus 8 is on the x value. So again, let's think about our definitions of transformations. So we now have y is equal to minus f of x plus 8. So we know that if you're adding or subtracting a constant to your x values as we are here, that this has got to be some sort of a horizontal shift. So to determine which direction we are shifting on the x-axis, we think about the x-intercept. So you have this x plus 8 is equal to 0. And if we solve for x here, we'll need to subtract 8 from both sides of the equation, which leaves us with x is equal to negative 8. So this implies that we are going to shift left 8 units. So we are shifting horizontally to the left 8 units. This is our second transformation. So again, we have our parent function, we have reflected across the x-axis, then we have shifted left 8 units, and now last but not least, again, looking back at our given function here, our goal, we notice that we're subtracting a constant of 5 from f of x. So we'll give ourselves a little bit more room. So again, thinking about our definitions, we have y is equal to minus f of x plus 8, and on the outside of that function, we are now subtracting 5. So remember, if you are subtracting a constant from the y value, from f of x, this means that we have a vertical shift down. So we are going to shift down 5 units. And we have officially attained that given function. So this is one method to list your translations. And again, the order matters here. So this is our first, second, and third transformations. Now, there is an alternative approach to this question that I'd like to look at with you now as well. So let's again think back to the ultimate goal. What are we trying to describe? Well, we want to describe the translations needed to attain minus f of x plus 8 minus 5. So looking at this, notice you have a greatest common factor of negative 1. So an alternative way to write this is to factor that negative out to the front, out on the outside of the entire function. So we have minus, and then brackets, f of x plus 8 plus 5. So here we have changed the order in which we'll list our transformations. So keeping the order of operations in mind, let's think about how this is going to proceed. So again, your basic graph or your parent function is still y equals f of x but this time we can't read from left to right or we'll produce an error. We want to work within these brackets first. So from within these brackets, the first thing I'm noticing is the x plus 8. And we already know this one. We know that if we have a function, y is equal to f of x plus that constant value, plus 8, this indicates a shift left 8 units. So from our parent function, we first shift left 8 units. And again, going back to our given function here, the next thing we notice within those brackets is plus 5. So thinking about our definitions of translations, we have y is equal to f of x plus 8, which we took care of in step 1. But now we have plus 5. So the second translation needed is a shift up 8 units. Excuse me, 5 units. We shift up 5 units because we have a positive 5. Now that we have worked within those parentheses and we've exhausted the translations within the parentheses, only now is it safe to think about what this negative is doing to the entire function. So we have y is equal to, and then we have our minus with those brackets around the original function, which is f of x plus 8 plus 5. So a negative like this on the outside of the function, we know is indicating a reflection across the x-axis. Right, so a great way to check to make sure that your translation is correct here is to double check, to take this negative and distribute it back through that function to make sure nothing has changed. So if we distribute that negative, we have minus f of x plus 8 minus 5, which is that original function that we're given. If we had switched around the order here, we would not be able to attain our original function. So just be careful. It's always worth the extra 30 seconds to check your work.